Using mixed wire gauges in a four-way switch circuit presents both a safety and a code compliance issue. The primary safety concern revolves around the potential for overheating. Employing a smaller wire gauge, such as number 12 wire, in conjunction with a larger gauge like number 10 wire, can lead to excessive current flow within the smaller gauge conductor. This increased current generates more heat due to the wire's resistance. If the current exceeds the ampacity of the number 12 wire, it can overheat to a dangerous level, potentially causing the insulation to melt or even ignite surrounding materials, thereby creating a fire hazard. The National Electrical Code, or NEC, stipulates that all conductors within the same electrical circuit must be of the same size. In this context, if number 10 wire is specified for a four-way switch circuit, the NEC mandates that the entire circuit, encompassing both the 3-wire and 2-wire sections, must be wired using number 10 conductors. This requirement ensures that the entire circuit has a consistent current carrying capacity, preventing any localized overheating due to undersized conductors. There are several consequences for using mixed wire sizes. Firstly, improper wiring practices, including the use of mismatched wire gauges, can void the warranty on electrical components and appliances connected to the circuit. Manufacturers design their products to operate within specific electrical parameters, and using incorrect wiring can compromise the product's performance and safety, leading to warranty invalidation. Secondly, a qualified electrical inspector will likely fail a four-way switch circuit where the wire sizes are mixed. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC and local building codes. They are trained to identify potential safety hazards, including undersized wiring, and will not approve an installation that violates these codes. Code violations themselves are a significant consequence of using mixed wire sizes. Violating the NEC is considered a serious offense, as it directly jeopardizes the safety of occupants and property. Electrical codes are established to minimize the risk of electrical fires, shocks, and other hazards. Ignoring these codes can result in penalties, fines, and legal liabilities. To ensure safety and code compliance, the correct approach is to wire the entire four-way switch circuit, including both the 3-wire and 2-wire sections, using number 10 conductors. This ensures that the entire circuit has a consistent ampacity, preventing any localized overheating and complying with the NEC requirements. It is always best to consult with a qualified electrician if there are questions or concerns about proper wiring practices. They can assess the specific installation and provide guidance on selecting the appropriate wire sizes and wiring methods to ensure a safe and code-compliant electrical system. The NEC Table 310.15b16 provides ampacity ratings for various wire sizes based on insulation type and temperature rating. For example, number 10 copper wire with THHN insulation, rated for 90 degrees Celsius, has an ampacity of 30 amps. Number 12 copper wire with THHN insulation has an ampacity of only 20 amps. If the circuit breaker protecting the four-way switch circuit is rated for more than 20 amps, using number 12 wire would be a violation of the NEC and could create a fire hazard. The general rule is to use the lowest ampacity rating of any wire or device in the circuit. For instance, if a circuit uses number 10 wire with an ampacity of 30 amps but connects to a device rated for only 20 amps, the entire circuit is effectively limited to 20 amps. Overcurrent protection, such as a circuit breaker or fuse, must be sized appropriately to protect the weakest link in the circuit. In the case of a four-way switch circuit, the circuit breaker should be sized no larger than the ampacity of the smallest conductor used in the circuit. If number 12 wire is inadvertently used in a section of the circuit breaker should be sized no larger than 20 amps to protect the number 12 wire from overheating. However, using a smaller circuit breaker does not eliminate the code violation of using mixed wire sizes. The NEC requires all conductors to be the same size, regardless of the circuit breaker size. The reason for this is that even with a smaller circuit breaker, the number 12 wire could still overheat under certain conditions, such as a sustained overload. Furthermore, using mixed wire sizes can create confusion and potential hazards for future electricians who may work on the circuit. They may assume that the entire circuit is wired with number 10 wire and inadvertently overload the number 12 wire, leading to a fire hazard. In addition to the NEC requirements, local building codes may also have specific requirements for wire sizes and wiring methods. It is important to check with the local building department to ensure that the electrical installation complies with all applicable codes. When working on electrical circuits, it is essential to follow safe work practices to prevent electrical shocks and other hazards. Always turn off the power to the circuit at the circuit breaker before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician to do the work. They have the knowledge and experience to ensure that the electrical installation is safe and code compliant. The NEC also addresses the issue of voltage drop in electrical circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Using larger wire sizes can help to reduce voltage drop, especially in long circuits. Number 10 wire has a lower resistance than number 12 wire, so it will result in less voltage drop for the same amount of current. In a four-way switch circuit, voltage drop is typically not a major concern because the circuit is usually relatively short. However, if the circuit is long or if there are multiple lights or other loads connected to the circuit, it may be necessary to use larger wire sizes to minimize voltage drop. The type of insulation used on the conductors can also affect the ampacity and voltage drop. THHN insulation is a common type of insulation used for electrical wiring. It is rated for 90 degrees Celsius and has a relatively high ampacity. Other types of insulation, such as TW and UF, have lower temperature ratings and ampacities. The NEC requires that conductors be installed in a manner that protects them from physical damage. This can be accomplished by running the conductors through conduit, such as EMT or PVC, or by using cable assemblies, such as NMB or UFB. Conduit provides a higher level of protection for the conductors and is often required in commercial and industrial buildings. Cable assemblies are typically used in residential buildings and are less expensive than conduit. However, cable assemblies are not as resistant to physical damage as conduit. The NEC also has specific requirements for the grounding of electrical circuits. Grounding is the process of connecting the metal parts of electrical equipment to earth, which provides a path for fault current to flow back to the source. This helps to protect people from electrical shocks and to prevent fires. The NEC requires that all electrical circuits be grounded, with a few exceptions. The grounding conductor must be sized according to the size of the circuit conductors. For example, a 15 amp or 20 amp circuit requires a number 12 grounding conductor, while a 30 amp circuit requires a number 10 grounding conductor. The grounding conductor must be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to earth, which helps to dissipate fault current. In addition to the grounding conductor, the NEC also requires that all metal enclosures, such as electrical boxes and panels, be bonded together. Bonding is the process of connecting the metal parts of electrical equipment together to create a low impedance path for fault current to flow. This helps to ensure that all metal parts of the electrical system are at the same potential, which reduces the risk of electrical shock. The NEC also has specific requirements for the installation of electrical boxes and panels. The electrical boxes must be securely mounted and must be large enough to accommodate the conductors and devices installed in them. The electrical panels must be installed in a location that is readily accessible and must be protected from physical damage. The NEC also has specific requirements for the wiring of electrical devices, such as switches and receptacles. Switches must be wired so that they disconnect the ungrounded conductor, not the grounded conductor. Receptacles must be wired so that the grounded conductor is connected to the neutral terminal and the ungrounded conductor is connected to the hot terminal. The NEC also has specific requirements for the installation of lighting fixtures. Lighting fixtures must be securely mounted and must be wired so that the grounded conductor is connected to the neutral terminal and the ungrounded conductor is connected to the hot terminal. The NEC also has specific requirements for the installation of appliances. Appliances must be wired according to the manufacturer's instructions and must be grounded if required by the NEC. The NEC also has specific requirements for the installation of motors. Motors must be wired according to the manufacturer's instructions and must be protected from overcurrent. The NEC also has specific requirements for the installation of transformers. Transformers must be wired according to the manufacturer's instructions and must be protected from overcurrent. The NEC also has specific requirements for the installation of generators. Generators must be wired according to the manufacturer's instructions and must be grounded if required by the NEC. The NEC also has specific requirements for the installation of solar photovoltaic systems. Solar photovoltaic systems must be wired according to the manufacturer's instructions and must be grounded if required by the NEC. The NEC is a complex and comprehensive document that covers all aspects of electrical installations. It is important to consult the NEC and local building codes to ensure that all electrical work is performed safely and in compliance with all applicable codes.